and welcome to Lemon TV. Today we're treating an entirely different topic, but still on physics. The Fleming's left hand and the right hand rule. And we'll be discussing on the definition of the left hand rule, the right hand rule, who Fleming is, the similarities and the differences. All of this we're going to discuss in the course of this video. Now, the Fleming's left hand rule and the Fleming's right hand rule is dated back to a scientist by the name Professor J.A. Fleming. In the early years, 1800s, in the same time with Faraday, he created these rules from his experiments. Now, the left hand rule, from the definition, is actually of this symbol. I hope you can see it. Of this sign, the left hand rule. This is my left hand, as you can see, and so I will also display it in diagram, something like this, and a little bit like this, if I'm not mistaken. The hands are not really straight, and then your fingers follow, something like this. Now, what the Fleming's left hand rule is trying to say is simple anyway. He said, extend your fingers, extend your hand in this direction. Extend your first three fingers. These are your first three fingers. This, and this. The thumb finger, the forefinger, and the second finger. Your thumb finger, the forefinger, and the second finger. Extend it like I extended each of them. You extend it, and then what does it form? Extend them so that they can be mutually at right angles to each other. Now, if you notice, this is at right angles to this one. Right angles means it's perpendicular. So this is perpendicular to this. This is perpendicular to this. And then if you look at it, this one is pointing horizontally. This one is vertical. So it's also, this is vertical rather. This is horizontal. And so they're also at right angles to each other. So put your fingers, your first three fingers, at right angles. Extend them in that direction. You form something of this. Something like this. So according to him, he said that this being the forefinger represents the direction of the magnetic field. The magnetic field in question. And then this represents the second finger. The second finger was the direction of current. The direction of current. While the forefinger was direction of force, or direction of motion of the force. Direction of motion of the force. Since force is a vector quantity, it means that it has magnitude and at the same time it has direction. So force is usually applied in a particular direction. So now what the left hand rule is trying to say is that when you pass current through a straight wire through a conductor, it actually exhibits some force in the presence of a magnetic field. Don't forget that you have a magnetic field, and then you apply a magnetic field. This is north, this is south, and it projects from north to south like this, something of this form. And he said when you have a straight wire actually has some principles which I explained in the initial videos. Now, when current is passed through it, it creates a magnetic field, concentric, and then this concentric interacts with this, causing the conductor to move in a direction perpendicular, in a direction that is also perpendicular to this magnetic field, at the same time perpendicular to the direction of the current. So each of these things are related and enter into the left hand rule. The right hand rule actually looks like this. Let me show it off again, like this. Can you see it? This is my right hand. So this is how it looks like, and then a finger pointing in this direction. and the thumb finger pointing upwards, the other fingers. This was not actually important. This is the only one that is important. These three fingers, they're important to us. So the right hand rule states that you extend the first three fingers of your right hand. The thumb finger represents the direction of motion of the conductor, the direction of motion of the conductor. The forefinger also represents the direction of magnetic field, while the second finger represents the direction of induced current. Now, I'll write it out. This represents the direction of motion of the conductor. Then this represents the direction of magnetic field. Direction of the magnetic field. And then finally the second finger here is the induced current. Now, what am I trying to bring out? It states therefore that when you have a conductor in a magnetic field, you notice that an induced current is created, and then some other processes like the movement of current to produce the induced current, then the preservation of energy, dissipation of energy from the induced current, induced EMF that is created. All of these things are interrelated and enter into the right hand rule. Now you may have wondered, what is the similarity between the left hand rule and the right hand rule? Well, all of those problems are solved right now. The left hand rule and the right hand rule are actually similar in a lot of ways, starting from the magnetic field. Now, I said that the forefinger in the right hand rule, and the forefinger in the left hand rule both stand for the same thing. They stand for the magnetic field, which means that in the left hand rule and the right hand rule, you either have a magnet or an existing magnetic field present to aid those processes. So what does that mean? That you have a magnetic field, which is one of the similarities between the left hand rule and the right hand rule. The second is that they both have current. Now, for the left hand rule, the current is entering, but for the right hand rule, the current is coming out, meaning that the left hand rule has current that is passed in, but here in the right hand rule, the current is actually coming out because it is induced, it is created. The induced current is actually coming out. So they both have current discussed in their rules. The third similarity which they both possess is that they talk about rotation and electricity. One produces the other in one of the rules, while the other produces the first in the other rule. So these are the similarities, basic similarities anyway, between the left hand rule and the right hand rule. We move now to the differences between the left hand rule and the right hand rule. Now, the left hand rule and the right hand rule, I have set them in a table to explain the differences properly. Now, firstly, the left hand rule is known as the motor rule, or the motor rule, anyhow you want to call it, the motor rule, while the right hand rule is called the dynamo rule. Another name for it can be the generator rule, because then the dynamo is a generator, and so it can also be called the generator rule. Now, this is one of the basic differences between the right hand rule and the left hand rule. Their names, the motor rule or and the dynamo rule. That's the first difference. Now, why is it called the motor rule and dynamo rule as I placed it? The motor rule, any kind of motor you see, a motor actually is a device that is used to create current, create rotation from current, from addition of current. It creates rotation from current. That is, when you apply current to a motor, it starts creating rotation. Our motor cars can be a simple example anyway. Like that, if until it is until you apply the necessary things, the fuel, start up the engine before the car start moving, the engine starts rotating or the tires start moving. So it is until current is applied mainly before the rotation comes. But for the generator, you know that the generators actually need these rotations to produce current. Like now, when you put in your fuel, the fuel goes into the engine and then helps it to start moving, helps the rotors in the generator to start moving. When you start up the generator also, it also causes the rotor to move at a great speed, thereby producing current. So now what does that mean? For the left hand rule, you have rotation produced from current. Rotation produced from current, which means it is until you apply current before rotation is produced. And this one is current produced from rotation. Current produced from rotation. So the reverse is the case in both ways. The left hand rule uses current to produce rotation, but the right hand rule uses rotation to produce current. That is what it means. Also now, examples of the left hand rule or equipment that are made with the left hand rule is your fan. You notice that your fan, any type of fan, maybe the standing fan, the ceiling fan, whatever type, all of them actually work the same way. It is until current is applied to your electric fan before it starts rolling. But for the right hand rule, it's simply your generator and other large devices used in industries. But your generator is the one you are very much familiar with. So when you apply your force to start up the generator, you notice that it produces light to the whole building. That light is actually coming because the rotation from the generators, from the engine generator, is producing the current. But for this one, the current is producing the rotations. Now, the left hand rule can be used in the application of the AC motor or the DC motor. The AC motors or the DC motors, while the right hand rule can be used in the AC generators. Now, most of these things are actually applied in the vehicles we use. So the knowledge of these things goes a long way. The left hand rule also discusses force on a conductor or a straight wire, but the right hand rule talks about production of the induced current, production of an induced current, which means that the final result for the right hand rule is current, while the final result for the left hand rule is force, which means that force actually brings about rotation. The force that brings about rotation is is the result of the left hand rule. Now the right hand rule also has its application in the knowledge of transformers. Unlike the left hand rule, but each of these topics, each of these basics have the applications in several appliances, industries, materials that we make use of. So far, we've dealt with the definition of the left hand rule, the right hand rule, the similarities and the differences. And I told you that it was all dated back to the Professor J. Fleming in the 1800s, and I told you the left-hand rule actually deals with the current, the applied current, the magnetic field, and direction of motion of the force, or direction of motion of that force that brings about rotation. While in the right-hand rule, we discuss, the current, but the current here is induced, the magnetic field, and then the direction of motion of the conductor in question. I told you that the similarities between the right-hand rule and left-hand rule are that they both have a common magnetic field. They discuss about the magnetic field. They both have deal with forces, currents, and they set up producing different results anyway. I told you the differences, which we discussed rather elaborately on in the differences. I said the left hand rule actually has to do with the rotation produced by current, and then the right hand rule has to do with the current that's produced from rotation. So each of these things apply in the fan, the electric fans, and the generators. I hope you enjoyed every detail contained in this video. To get more information about the right hand rule, you could look up to your screen right now and see the information about the electromagnetic induction. You could read it up there, the principles of the electromagnetic induction, the Faraday's law and the Lenz's law. These two things actually give an idea on how the right hand rule works. And meanwhile, having enjoyed the video, I would encourage you to subscribe to the channel to get more interesting videos. The next we'll be dealing with is on mathematics. We'll be dealing with the gradient and the equation of the straight line. The gradient and the equation of the straight line. To get it, I will encourage you to subscribe. Thanks for watching.